Hi, welcome to the fall 2021 edition of the Shop Talk. This is Aki Fujimura. I'm CEO of D2S, a managing company sponsor of the eBeam initiative. And today we welcome Hayashi-san from DNP. He's a research fellow of DNP, and he has done so much for the mask industry. He really needs no introduction at all. Thank you, Hayashi-san, for being with us today, and look forward to it. First, let's start with a question about what your impressions were from the recently completed Photomask Technology Conference. What did you think?
Yeah, so I think that there are not so many, new things. But and also this time, the SPIE conference is doing a live presentation. So because of the time zone difference, I could not see the all things, especially for the mask-related one in real time. But I pick up the two things. One of them is like a multi eBeam inspection technology. Maybe it's the first time to announce from New Flare. That's very interesting things. And also the EUV pellicle progress from several presenters kind of things. So that's very impressive for me. Yeah.
Yeah, pellicles are really important, and inspection is the other thing in EUV. So we'll talk a little bit about that later. One of the questions that comes up in the eBeam initiative event that we hold every year at Barca's conference is the luminary survey. And this year again, we asked the luminaries what do they think is the reason why multi-beam machines are being purchased? And it's consistent again from last year to this year that EUV is the number one reason, and curvilinear mask is the number two reason. I wanted to ask you because we know that you've published a lot of results with multi-beam. You were one of the visionaries in the industry to adopt one of the first multi-beam machines, and I know that you had uses other than just EUV or curvilinear. So can you talk a little bit about how you've been using your multi-beam machine and what you see as the general case?
Yeah. Yes, our primary purpose to get multi-beam mask writer is, of course, to write a very complex features masks like EUV and curvilinear type, mask kind of things. But also we need a very precise resolution for our nano imprint template kind of things. So the multi-beam mask writer has a good advantage of constant writing time, but it's a kind of the trade-off of resolution sometimes. So our system has capability to switch the beam size from 10 nanometer to 20. So 10 nanometer for precise resolution for imprint, and 20 nanometer for the good throughput for complex mask kind of things. So such kind of the flexibility is I think it's a good advantage for multi-beam mask writer compared with the current DSP. So,
yeah, sounds good. Do you think that even more bigger pixels or even smaller pixels than 10 nanometer? I mean, like what do you think is the future of multi-beam machines?
Yeah, that's a good point. So like a UV mask, maybe a next generation UV mask need quite small assisted feature kind of things. In that case, maybe we need a more smaller beam size, maybe less than 10 kind of things. And also like nano imprint area is also, the scaling is also growing. So that maybe smaller beam size for resolution is needed. And also the in your survey, like a mature node photomask volume is still there. So that maybe a bigger beam size will help throughput time of mature masks for productivity kind of things. So at the both sides. So our IMS multi-beam mask writer has a capability to select, I think it's the 4 kinds of beams. So that's a flexibility. It's a good help to cover the wide area of a photomask, requirements.
Yeah, that's very interesting. Yeah, so you might want to have a constant write time mask writer even for the more mature nodes, right?
That's right. Yeah.
Yeah, interesting. Yeah, that's good. That's really, really interesting. So multi-beam mask writers will definitely help on the EUV side for more reasons than just a constant write time. But EUV turnaround time in general, so mask writing itself will be constant write time, but the rest of the infrastructure like data preparation or inspection and repair and so on, do you think that there will be any impact with EUV TAT?
Mm-hmm. Yeah, I think that now EUV lithography is adopted in real products in high volume manufacturing. So in that case, we should take care of the quality of the mask rather than the evaluation mask kind of things. So I think that most of the turnaround time extension will include the quality assurance time. For example, the inspection of the defect and also the particle, even on the backside or side of the mask kind of things. And also the uniformity is very important now so that the measurement point of critical dimension or EUV reflectivity is going up. So that such kind of quality assurance time is getting longer, I think.
So EUV being smaller features and requiring more precision because EUV lithography is more precise. So mask has to be more precise and all these things for your point, I think, is high volume manufacturing use is going to require much more stringent quality assurance, and that is going to cause lengthening of the turnaround time. I see. Yeah. Yeah. And what do you think about potential for curvilinear EUV shapes? So actually, curvilinear shapes in general. Are you starting to see them now, or not yet?
Still, even in a 193 immersion mask, the curvilinear features adoption is a very limited area. So that with the current inspection tool or repair tool kind of things, our engineer can handle curvilinear features in the present time. But maybe if the customer would like to adopt, this kind of technology in full field, maybe we need to, revisit this area to improve the inspection capability, kind of things. Yeah.
So you can handle today's kind of limited use of curvilinear shapes, no problem. But there might be areas of improvement in a bit. Which particular areas need improvement? And is it like inspection kind of areas, or is it more like upstream areas, downstream areas?
I think that mostly inspection areas and also the maybe the measurement of the features critical
Metrology.
dimension. Yeah, that's not a straight line now. So
So, speaking of inspection, do you, other than curvilinear, or maybe even including curvilinear and curvilinear EUV, to take it to an extreme, what are you seeing as the need for improvement in the inspection area?
oh yeah, definitely the scaling is impact on the inspection because of the like assist feature of the EUV mask for 3 nanometer and beyond. It's quite small, maybe less than 20 nanometer kind of things. So in that case, the inspection resolution should be improved. But also maybe we need another method to inspect such kind of the feature like a aerial image type inspection system will be needed, I think.
Aerial image on the wafer, you mean?
Yeah, that's right. Yeah, aerial image on the wafer. Yeah.
Yeah, so it's like a wafer plane analysis, and you mean like using AIM? So you mean take a picture on the mask and do aerial image simulation on it?
Yeah, basically
Maybe either.
yeah, maybe the AIMS type with EUV source
Light
to
source.
inspect the mask and analyze the captured features and simulate the image on wafer. So
Mm-hmm. So you're looking to be able to differentiate between 20 nanometer problems that matter on the wafer and ones that make no difference on the wafer, right?
that's right. Yeah,
Yeah, yeah. Are you seeing the number of repair, number of sites that need to be repaired to be a problem in the future? Maybe not now, but do you think it's going to be a problem in the future?
yeah. I think it's could be a problem in the future because of pattern density and also the quality requirements.
Mm.
So we should think
Yeah.
about that.
So that means that particularly for EUV inspection, like automatic defect categorization becomes an important thing. You want to be able to tell if you need to repair it or not. Maybe wafer plane is one of them. But how about deep learning, deploying deep learning into ADC? You've talked about that before, to me, the great thing about deep learning is image processing, and also it can do better than humans, particularly in large volumes of analysis. So it seems like an ideal application. How is it going with trying to deploy deep learning in ADC?
Yeah. So I think that deep learning is very effective for inspection area, especially for the defect categorization kind of things. But deep learning needs much more, many learning data to make a precise model. So in a mask area, maybe the memory kind of things, we can get good, number of learning data because the feature is repeatable kind of things. And also our DNP is working also non-semiconductor high volume manufacturing products kind of things. Also, we need inspection technology. And in that case, the product is about the same features all day, so that it's easy to get learning data of the defect. But especially in the mask of logic device kind of things, it's quite difficult to get the learning data of the defects kind of things. So that maybe we need a kind of digital twin to make such kind of the learning data to educate, the deep learning.
Right,
Those
that
kind of
depends.
things. Yeah.
Yeah, I think so too. I think particularly since you are so good at not making defects, right? Even though you have more defects than you like, you still are really good at not making defects, particularly if you have a particular kind of defect that deep learning network is confused by, and it needs to be unconfused by giving it more data. You can't be having to produce that specific data every time that happens, right? And so I think digital twin would be very helpful. Yeah. So that's it's great to hear that you think that adoption of deep learning technology for automatic defect categorization is very promising, and that you're heading in that direction.
Yep.
Yeah, that's great. Yeah. Okay, well, thank you very much. It's a very broad area, not surprising for you because you're always able to navigate through so many different spaces. Chemistry, lithography, your customers' problems, your vendors' problems. You're so well versed in so many different areas, and it's always amazing to be able to talk with you. Thank you very much, Hayashi-san.
Yeah, it's also my pleasure. Thank you.